Hello everyone, welcome back to my Chem Corner. So in this video, we are going to discuss on the second PUC passing package. So we're very fortunate that in chemistry, there are certain questions which are really known to us, and it helps students write exam easily. So those are the questions that I'm going to discuss, or rather topics that I'm going to discuss over here. So please ensure you have your book and a pen, and you're going to make a note of all this, and ensure that you're making this thorough first, and then moving on to the other questions. So I'll give you the questions chapter wise. Along with that, the marks allotted to these questions regularly in most of the board exam papers. Alright, so before moving to the video, if you're new to the channel, please do hit the subscribe button and the bell icon so you receive notifications whenever I upload a new video. So let's start on with this. Now in the second PUC passing package, there are some of the questions that are compulsory there in the paper and are repeatedly asked every year in the paper. Now that could be a 4-mark question, it could be a 3-marker or a 1-mark question. So please make a note of it. So first thing is, let's look into the physical chemistry questions. Alright, now in physical chemistry, the first chapter that I'll be focusing on is solid state. Alright, now in solid state, there are some of the questions that are repeatedly asked every year, and one of them is going to be packing efficiency. Alright, now under packing efficiency, what is asked is, they can either ask you a definition and the derivation. So we have learned 3 derivations, which is for a simple cube, BCC and FCC. So we have learned these. Now out of these 3, if any one of these are just asked for derivation, then they will be asked for a 3-mark. Alright, if they're asking along with the definition, then it's going to be for a 4-mark question. At some point, they also ask for 5 marks. So the only possible 5-mark question directly asked is entirely based on packing efficiency, which will include the definition. Now, how is the pattern that you're going to write the answers to it? Because as a teacher, I do see a lot of students' papers where they only write the calculation. Sometimes formula is forgotten, sometimes substitution is not done, sometimes unnecessary calculations are done to these, which is not needed. So what are you going to write under this? If they ask derivation, diagram is most important, because that is what keeps the difference between a simple cube, BCC and FCC. Trying to show the position of the lattice points, trying to show what you're calculating, shows a big difference in each of this. So diagram is most important. Label the diagram. Second thing is to show the Pythagoras theorem. You need to show the Pythagoras theorem in each of this. If they have 2 Pythagoras theorem, then you need to show both of it. So after this, what you need to write is the Pythagoras theorem. Now once the Pythagoras theorem is written, you need to show the calculations of A in the Pythagoras theorem. Once the Pythagoras theorem is done, put relevant values and show A value. Now once that is done, you need to write the formula. Formula should be written completely. You write the entire formula and you show the substitution to the formula. Now once you've done the substitution, there is no need for you to further sit and calculate that entire substitution. You know that the direct answers to it is 74%, 68% and so on. You can just write the percentage directly, because further on after substitution there is really no marks for calculation there. So once you write the substitution, put the percentage directly. So this entire thing has to be mentioned in the derivation for packing efficiency. After this, the second question. So this is going to be a sure shot 3-marker in the question number 37, A part. Now what about 37B part onwards? Now 37B part can contain a difference between amorphous crystalline solids. So the very first page of your chapter, you're learning an entire table with so many differences. You're talking about the geometric shape, you're talking about the melting point, boiling point, you're talking about anisotropy and isotropy. Out of this, you can learn any 3 points. That is more than enough. Learn any 3 points thoroughly, because this question can either be for a 3 mark or for a 2 mark. As per the mark, write that many points only. You don't have to really write more than that. So a difference between amorphous, crystalline. Then another difference that they can ask is difference between Frankel and Schottky defect. Alright, now under Frankel and Schottky defect, you will be asked to write any 3 points. Again, this is another question that can be asked either for a 3 marker or for the 2 marker. Now under this also, basic definition you can write. You can talk about the density change. You can talk about the size of the cation used in all of these. So these points you can write under them. Whenever you write differences points, please ensure that you put them in a table. That makes your presentation very simple and neat. So these are the two differences that they can ask from this chapter. Then another one is your problems on density. Alright, now the density formula is D is equal to Z into M by A cube into Na. So this is the formula. Based on this, they can ask you to calculate what is the Z value, what is the M value, or what is the D value. So other things will be given to you in the question. So this is one of them that you have to, you should be practicing. There are a lot of in-text questions that are solved in your problem, and I'm sure your teachers would have done some of these in your class also. So go through these and try to learn simple problems, direct substitutions to it, because as per PUC syllabus, we don't really ask a very difficult question problems. Alright. Please remember that the density should either be in gram per meter cube or gram per centimeter cube. Alright. Now, the next one that can be asked in this one is a definition on magnetic substances. So towards the end of the chapter, we have different types of magnets: ferromagnetic substances, antiferromagnetic substances. So any one of the definition of the magnetic substances with one example under each. Now this will be a 2-mark question. Density problem can also be another 2-mark question. One thing that I forgot to mention is whenever you write any numerical, you have to write a formula which will carry 1 mark. The substitution to the formula will carry 1 mark, and final answer with unit will carry 1 mark. This is the mark distribution for problems on density. Alright, so the last one, as I mentioned to you, is a definition on magnetic substances, where they will ask you the definition of one of the magnetic substances with an example under each. One example under each. Alright, now for the others who are aiming for more marks, more percentage, I would suggest you to go through the entire thing that is shown in the textbook. These are only for the pass package. In this also you will get really good marks if you ensure that you know 100% of pass package. Alright, so that is the first chapter of physical chemistry. Now let's move into the second chapter. In the second chapter, I'm going to talk about solutions. Chapter name is solutions. Now, this is from question number 38 this year. As per the new pattern, I'm giving you the question numbers for part D. So, please follow that. Now, in this, your first question that can be given as a short 3 mark is a problem on colligative property. Alright, it's a problem on colligative property. We have 4 different types of colligative property. One is relative lowering of vapor pressure. Then we have elevation of boiling point, depression and freezing point, and osmotic pressure. Out of these out of these 4, any one problem as per how it is solved in the textbook will be asked. Again, this is a 3-mark, short 3-mark question. So please ensure you are learning it. For this also, the 3 marks are divided the same way as the previous chapter. Formula will carry 1 mark. Substitution will carry 1 mark. Final answer with unit will carry 1 mark. Alright, so this remains the same. So that is a short 3-mark question, this one. Now, the second question out of this is the statements for Raoult's law. Raoult's law, we have 2 statements under 2 different conditions. Both Raoult's law you should know, because sometimes when they ask Raoult's law, they are mentioning it specifically in the question paper. So Raoult's law, and the second one is Henry's law. Now, one thing to be taken care of in Henry's law is you should know the statement and the mathematical expression. Alright, now this is a 2-mark question. Raoult's law alone is asked if it's a 1-marker. Henry's law with this mathematical expression is going to be for a 2-marker. Then the third one is you have 2 differences here. Just like the previous chapter, you have 2 differences. Differences between ideal and non-ideal solutions. Alright, now this can be for a 3-mark question. So under this you can write basically what an ideal, non-ideal solution. They obey Raoult's law, they don't obey Raoult's law. Then you can talk about the interactions between the solvent, solute, or solvent-solute interactions. Then you can talk about the enthalpy of mixing, the enthalpy of volume, the volume, mixing of volume and all of that being 0 and not being 0 in terms of non-ideal solution. All these things you can talk about in a 3-mark for a differences. Then another difference that they can ask is difference between positive and negative deviation from Raoult's law. Alright, now this is also another 3-mark question. Same thing you can talk over here. You can tell what a positive negative deviation is. You can tell about the type of interaction that's dominating here. What sort of an interaction dominates here. Then you can talk about why is the positive negative deviation happening by taking a certain example that you can tell. You need to tell the reason, not only take an example, but tell a reason to it. Why is it so? What is the reason and all of that? So those you can answer for a 3-mark, 3 points. Alright. Another one for another, 2 marks that they can ask is a short note on reverse osmosis. Now this is a 2-mark question. So you can just write in general what you see by giving its definition, what happens and things like that. So that is a 2-mark question. Then another one that can be frequently asked is for a 1-marker on a Van 't Hoff factor. The value of I when a certain salt undergoes dissociation. And you need to write what is a Van 't Hoff factor for it. This is again a 1-mark question. So these are the possible passing packages from this particular chapter. Alright. Now next one is chapter number 3, which is electrochemistry. Alright. Now under electrochemistry, this belongs to question number 39. Now in this again, one of the short question that you can have is a problem on Nernst equation. So either you can have a problem on Nernst equation, or a problem on the ionic conductance, where you're trying to calculate molar conductivity for a strong electrolyte or a weak electrolyte, or conductance. So you have a problem based on this in your textbook as well. So either it could be a problem on Nernst equation uh, from the first half of the chapter, or you can have from the second half of the chapter, which is ionic conductance. That is for a 3-mark question. Apart from this, you can also be asked construction of standard hydrogen electrode. Now when you write this, what is important is, if asked in the question, diagram is important, a neat labeled diagram. Then you need to know what is the E0 cell value for SHE, the cell representation, as well as the overall cell reaction. These are important things when you look at construction of SHE. Alright, so that is again for another 3-mark question. So possibly in a 3-mark, what can be asked is these. Alright, either they can ask a problem on Nernst equation or a molar conductivity or construction of SHE. So these are possible questions that can be asked. Apart from this, what other questions can they ask? You have those part in the chapters that have cathodic and anodic reactions, right? Cathodic and anodic reactions. Where do they come? They come under fuel cells, they come under batteries, and they come under corrosion, right? So these things come from here, and that is for a 2-mark question. Alright, so cathodic anodic reaction, fuel cells, batteries, and corrosion can come for 2 mark. Now, apart from this, you can also have problems on you have delta G problems and you have K problems also. But these are the ones, the problems where your Faraday's constant is involved, right? The Faraday's constant. So those you can the F value, using the F value. So you can get problems on these, which is another set of questions which is for a 2-marker. These are coming from the equation of Nernst equation. So from there you have another two set of it, so they can also be asked over here. So these are the type of questions that they can ask from electrochemistry chapter. Mostly they are problem based or equation based. Hardly you get any directly asked questions from electrochemistry. Alright, then we have the 4th chapter, which is chemical kinetics. Alright, chemical kinetics is question number 40. Now here, one of the 3-mark question that is for sure there is the derivation on integrated derivation for 0 and first order. We have done those derivations, right? For integrated rate equation for a 0 and first order reactions. Out of that, any one derivation can be asked for a straight 3-mark. Now, quite possible that you can also get a problem based on these derivations. It could be either on integrated rate equation or it could be on half-life, any one. Alright, so then it's going to be a 2-mark question. So make sure that this entire part of that particular chapter is made thorough. The derivation followed by numericals. Alright, then what is asked is effect of catalyst. You remember the graph that was learned towards the end of the chapter, where you draw the graph and you show 2 curves in it, one depicting in the absence of catalyst, the other depicting in the presence of catalyst. So you have to learn the graph, label the graph, and explain why there's a change in the rate of reaction and what effect does a catalyst show on activation energy. Alright, so this is again a 2-mark question. Then the 4-mark is factors affecting rate of reaction. Factors affecting Rate of reaction is again a 2 marks. So you can talk about activation energy, proper orientation, collision frequency, and many factors like that. So you don't have to explain any of this. Like I've told you in PUC, it's a very straightforward questions that are asked. Unlike CBSE, where it's a lot more conceptual based and you need to spend your time. So as long as you're in PUC, I'm sure your teachers have trained you to answer your questions directly. Then unlike the CBSE board, where you are trained to answer those kind of questions in a different way. So here it's very directly asked questions. You just have to write the factors and not explain them at all. Alright, so that is one thing. Rarely you have problems, because it just was there in 2 or 3 questions, problems on EA and on activation on Arrhenius constant. Very rarely they've asked, which is again for a 2-mark question. Alright, so these are possible questions, but this is a sure shot question, these two. Alright, so these are the type of questions that are asked in chemical kinetics. Alright, so now the next one is going to be on surface chemistry. That is the last chapter under physical chemistry. Alright, now this is going to be question number 41. So under this not much of really that you can say, oh, this is a short question or something like that, but possibly asked questions, repeatedly asked questions every year. I can tell you that. So first one is differences. There are a lot of differences in this chapter. So I'll tell you those differences. So differences, first part that you can get is on physisorption and chemisorption. Alright. Then they can ask another one on possibly on adsorption and absorption. Very basic difference. Then they can ask is on lyophilic and lyophobic colloids. So these are the types of questions that they can ask for differences. Please remember that if it is physisorption, chemisorption, it's a 3-marker. Lyophilic, lyophobic is 3-marker. These two are going to be only for 2-marker. Alright, then after this is a note on missile formation. How missile formation takes place. Explain the formation of missile. Is a 2-mark question. Then what else they can ask is, you have those table of examples with the different dispersion medium and dispersed phase. One example, so they can ask you, give an example of a colloid formed whose dispersion medium is solid and dispersed phase is a liquid. So you can ask for the type of colloid formed there or an example of it. Those kind of questions can be asked. Alright. Then another possible question that they can ask is the mechanism of adsorption. So you have learned, okay, first is going to cause adsorption, then there's going to be a chemical bond formation, which is chemisorption. Then once that has formed, they form the desired activated complex. Once that is done, then it's going to leave the site producing products and things like that. So you have 4 points under it. So mechanism of adsorption can be another question that is asked. After this is certain definitions that they can ask, certain difficult terminologies that you've just started learning in surface chemistry. For example, is something called as a zeta potential or an electrokinetic potential. One example, a definition of this can be asked. Or what is coagulation? What is coagulation? Or what is precipitation of a sol? Those things can be asked as definitions. Alright, so definitions for 1 mark can be asked. Then they can ask you to explain is certain phenomenon that is seen in purification of colloidal solution. That could be, say for example, they can ask you to explain dialysis or electrodialysis or they can ask you to explain the phenomenon which is Tyndall effect and Brownian movement. These are like 2-mark questions. Tyndall effect and Brownian movement can be asked as explanation. There's also another process called as ultrafiltration. So these things can be asked for this. Apart from this, there are some chemical methods where you're preparing the salt. Please go through that and make sure you know those preparation methods, especially the Bredigs arc method, where you're doing that when you know how to draw the diagram for it as well. Alright, so that is also an important part of the chapter. So the reason why I've given you this is because in NCRT, if you see the type of information provided, students can get panicked because I'm sure most of you are dependent on your teacher's notes, on your own notes that you've taken down in class, and suddenly when you look into your textbook wondering, there are a lot of topics to be learned. I'm sure this video is going to help you all in learning those important things that you need to know when you go for writing your exam. So before you write your exam, please ensure that you watch this, ensure that you know 100% of this. I'm sure this is not just for past package, because like I've told you, a lot of these are there in your question paper. All right, and if you try and count the marks, if you just take your older papers and if you try to compare with these topics that are shown to you in the video and you try to compare it, I'm sure you're going to get more than passing mark at the end after counting. So please ensure 100% of this is learned and not just a few topics. Then it's not going to help you all. You have to learn 100% from here. All right. Since it's a very longer video, it is almost coming up to 25 minutes. Putting in the information for inorganic and organic will make it too long. So I'll make this as a single video only for physical chemistry, and I'll also be uploading for inorganic and organic chemistry separately. So please do wait and watch those videos. So it's going to help you all to get more marks in your second PU board exam. Alright, so I'll see you in the next video. Thank you so much for watching.